Okay, so last time, um, you know, anybody know if there's any way to completely get rid of the uh, sidebar that all the people are showing? Anyway, you'd think I would know all of this. So last time when we left off, we were talking about the rules for what C++ does if it encounters an expression that involves both ints and doubles. And I just wanted to go through a couple of examples with you. And I promised I wasn't ever going to use this laptop again, but I decided it might be okay to use if I just have a USB mouse instead of trying to use the trackpad. So that's what I'm giving that a shot. So just to quickly review, the rules are if an arithmetic expression has one int operand and one double operand, the int is temporarily converted to a double. Rule number 2 is about assignments. And the rule there is that C++ will automatically convert the value on the right side to match the type of the variable on the left side. So I want to just stop for a minute. And I don't know if you all have, I don't know, a piece of paper you can scribble on, or if you can do this on some other window that you have open. But I'd like you to write down or type what you think I is going to be equal to after this sequence of statements is executed. I'm going to give you like 1 minute to do that. And then we'll go on. Okay, so if I'm not quite sure the best way to do this, but if you wanted to either just kind of unmute yourself for a second and tell us what you think the answer is, or type it in chat. Let's just get an idea of what people are thinking the correct answer is here. Everyone likes chat better than muting, which is fine. Okay, so let's work through it just to make sure everyone is on the same page here. So now, if I was doing this in a classroom, I'd be drawing boxes on a whiteboard. But let's just talk through it, I guess. So X is a double. So when I say X gets 11, there's actually going to be a conversion taking place there, right? Because this 11 here on the right, that's not a double, that's an int. So C++ is actually going to convert this int into a double. And then it's going to assign X the value 11.0, right? So we actually write it as 11.0 as sort of our human way of indicating that C++ is storing this, or the computer is storing this, not as an int, but as a floating point number. Okay, and then the same thing here. Y is a double. I cannot keep straight which keyboard to type on. A Y is a double, 4 is an int. So I'm going to convert the 4 into a double, and Y is going to be assigned the value 4.0. Then down here, when I say X divided by Y, X and Y are both doubles. So 11.0 divided by 4.0 is 2.75, right? And so now though, I've got an int on the left here and a double on the right. So I have to convert this double, 2.75. I have to convert that into an int before I can assign it to I. When I convert a double to an int, I just truncate it. So there's no rounding, I just truncate it. And so it's going to get the value 2. So I is going to be 2. Okay, any questions about that example?
I know this is a dumb question, but is double equivalent to float like in Python?
That is a great question. Double and, well, actually C++ also has a type named float. We typically use double instead of float because the double is more precise than float. The reason it's called double is it takes up twice as much memory as a float does. But essentially, other than how much memory it takes up and how precise it is, they're the same thing.
Okay, thank you for the clarification.
Okay, let's do another similar example. Let me, oops. Oh, no. Wow, okay, give me a second. Wrong people. Yes, I'm working faster. Pretty sure I have this. All right. Serious issues here. All right, here's what I'm going to do. I'm just going to type it. Okay, I'm going to have an int, another int, double. 4 x. Okay, same thing here. I'm going to give you 1 minute to figure out what the value of x is going to be after that last statement there is executed. What's the value of x? Mhm. Okay, so let's just run through it real quick. So I gets 11, no conversion is necessary at that point, right? I is just 11, j gets 4, no conversion is necessary at that point, j just gets 4. So here I have I divided by j I and j are both integers. So when I divide 11 divided by 4, the result is 2. And then when I go to assign the value 2 to x, that 2 is going to get converted into a double. So it's going to be 2.0. So yeah, that's correct. 2.0 is the correct answer. Any questions about all that stuff? Okay. So far we've talked about type int and type double. The next type that I want to spend a couple of minutes talking about is type char. And so a char variable is just a variable that can store a single character. So just like with integers, we can declare an integer variable and we can store a literal of type int in it. And we can store, we could declare a variable of type double, and we could use that to store a variable, I'm sorry, a value of type double in it. Let's just do a couple of those. I give 7, double x, x gives 14.35. We can declare a variable of type char, and then we could use that variable to store a literal of it's a character, so literal of type char. So let's just do like question. Okay. If I remember correctly, Python doesn't have type char, it just has strings, right? So in C++, we're actually going to have 2 different types. We're going to have strings, and we're going to have char, which just stores a single character. Let me just see what else I want to say about this here. So in C++, if you use single quotes, that makes it a literal of type char, right? We already saw that if we want to, for example, if you want to output a string, we use double quotes. So in C++, double quotes around something makes it a string literal. Single quotes around something makes it a char literal. The way that chars are stored in the computer is that each character has a number that is associated with it, and so the computer just stores the number and then converts it to the corresponding character when it needs to. You've probably, I'm guessing most of you are probably familiar with ASCII. If we wanted to, we could take a look at the website asciitable.com, and we can see, for example, the number 32 is the ASCII code for a space. The number 65 is the ASCII code for uppercase A, and so on. Now, having said that, I will say that you should, in your programming, you should avoid actually using this table if at all possible, and it usually is possible. I'm tempted to say it always is possible. As far as I know, it's always possible to avoid. But sometimes students will get excited about actually using the ASCII code for a letter in their code, and typically that's not a great idea because most people don't have the ASCII table memorized, so it's probably better to actually use the letter itself or the character itself. Okay, let me just do a couple of more examples like we did before with double, except using characters this time. So I'm going to say M X. Okay, so I want to, I don't want you to type in the answer to this just yet. I want to give everyone a chance to think about it for a minute. So please wait until I give you the word before you start telling me what you think the answer is. But the question is, what is the output of this code going to be? And sorry, I'm having a little trouble getting back to it. Okay, so this is a fairly quick one. So why don't you just go ahead and tell me what you think is the output is going to be? Right. Yeah. In this particular case, you can actually just skip everything and look at the cout statement, and nothing else really matters, right? Because X is not a variable. X is a literal. But I'm just going to change this slightly to give us another problem to work on. What happens if I just remove those quotes and don't answer just yet? Take 30 seconds to think about that, and then we'll talk about it. Okay, so what's going to get printed now? Time for typing in the chat again. Right, everyone says M. Okay, that is correct. There's a way to make this figure. Right, so at this point here, we're saying we're going to have a variable named M, and it's going to have the value X in it. And then at this point here, we're going to have a variable named X, and it's going to have the value M in it. And so here, when we say cout X, because there's no single quotes there, what we're saying is we're saying print out the contents of the variable X. And at this point, the contents of the variable X are M. Let me just go back to show you how I would draw this if I'm going to draw it. Right, here's example 2, right? So after we declare M and X, they just have junk in them, right? And then when we say M gets the character literal X, the picture's going to look like this. X still has junk in it, M has the character literal X in it. And then after we say X gets the character literal M, this is what the picture looks like. And so when we say cout X, we look up what's in X and print. Okay. And then I think you guys are getting the hang of this. So I'm just gonna go over the next example just quickly here. What I did in this example is it's exactly like the one before, except I took off the quotes around the M. So now, after I say M gets the character literal X, the picture looks like this. You guys can see my cursor, right? So like if I'm hovering over something and I say looks like this, you know what I'm talking about. I've never seen that's the case unless someone's looking at it. And then after I say X gets M, this means X gets the contents of the variable M. So the contents of the variable M is the character literal X. So that's why there's an X in here now. And the result when I say C out X is going to be that an X comes out. So anyway, if you got a little bit lost there, I would encourage you to just take a look at this later, maybe even type it in and execute it. Make sure you understand what's going on with those examples. Okay, so we've talked about int, we've talked about double, we've talked about char. Let's talk a little bit about string. Similar idea to the other three types that we've already talked about. I can say string, whoops. I can say string for one, then I can assign a string to it. I can print it out. Things like that. So a string consists of a sequence of 0 or more characters. So believe it or not, you could actually have a string that has 0 characters in it. So I could say, whoops, that should be stir1. I could say stir1 gets like that. It's a 2 double quotes right next to each other with nothing in between. That just means it's a string with 0 characters in it. That's perfectly legal. You can read strings using cin, just like you can do that with the all the other types we've talked about. Interestingly, you can add 2 strings together. I think you can do this in Python too, right? I can't remember if the syntax is the same or not, but if I have string stir2, stir3, and then I say stir1 gets hello, stir2 gets there. I see that I spelled that wrong. And then I could say stir3 gets stir1 plus stir2. And then what's going to come out, oops, is hello there, right? Let's actually try that. How do I make my controls go away? Driving me crazy. Okay. So debug, start without debugging. And there you can see that stir3, when I print stir3, it comes out hello there. Okay. Um, so just one thing that's a little tricky about the plus operator, it has this limitation, and that is that at least one of the operands must be a string variable. So for example, I can't say stir3 gets hello plus that gives me a syntax error, and the error message isn't going to make any sense at this point. You'll just have to take my word for it that the reason I'm getting that syntax error is because you cannot use the plus operator with two string literals. At least one of them has to be a string variable. So just something to be a little careful about. String variables are a little different from the other types we've talked about. Strings are actually objects, which is something we're going to be talking a lot about later in the course. We're going to be writing our own objects later in the course. But what that means is that with strings, we can do interesting things like I could say, actually, I want to bring, hold on. Stir3 bits plus 2, cout stir3.length. So the thing about objects is you can put a dot after the variable, and then you can put a function call, and you'll get some result. You cannot do that with int or double or char. If you try that with an int or a double or a char, if you put a dot after it, you'll just get a syntax error. So in this case, length just gives me the total number of characters in the string. So someone will tell me what this is going to print out on the screen. Just checking to see if anyone is still there. Yes, I think 12 is correct. Any questions about that? Okay. One more thing that you can do with strings I'm going to go over now that will probably come in handy at some point in the next few weeks is there's a function called substir. It takes two arguments. Let's say if I put a 3 as the first argument and a 4 as the second argument. What that is going to give me is it's going to give me a part of string 3. So string 3 is hello space there exclamation point. The substir function, the 3 there means start with the character at position 3. The positions in a string start at 0. So when I say, so which character is at position 3 in stir3? Is that I guess that's a lowercase l. Yeah. So, right, actually, I guess in this case, doesn't do a very good job of illustrating the fact that counting starts at 0, right? So the character at position 3 is that second L. Everyone okay with that? And then the 4, and be careful here because this is counterintuitive for some students, but the 4 tells me how many characters are going to be in the substring. So in this case, stir2 is going to get equal to LO space T, because the 4 means that you're going to get 4 characters. A lot of students intuitively will think that this means give me the substir that starts at position 4 and ends at starts at position 3 and ends at position 4. And as a matter of fact, in Java, that's exactly how it works. And I don't remember which way Python does it. But in C++, that second argument means that's how many characters there are going to be in the substring. Okay, so in this case, the output will be LO space T. Let's give it a try. Okay, any questions about any of that? Okay.
I have a quick question.
Sure.
So what's the overall difference between char and string then?
The overall difference is that a char is always exactly 1 character. A char can't be a sequence of characters. As a matter of fact, in C++, the way that the string type is implemented is it has a sequence of variables of type char that make up the string.
Okay.
So
Thank
you could
you.
argue, why do we even have char? We could just use string all the time and you would be correct. But that's what we have.
Thank you.
Okay. Okay, I think what I want to do is I want to just go take a look at the lesson. Most of the rest of the stuff I want to talk about is stuff that it's probably easiest to just look at the lesson while we're doing it. So I want to talk a little bit about programming with style. If you took a look at the syllabus, which I hope you did, you will see that this is something that I emphasize quite a bit, in particular when it comes to your grades on assignments or on labs. And then there's, at the end of the syllabus, there's about 3 screenfuls, I guess, of style conventions that we are going to be using in the class. So let me just motivate that a little bit. So getting our programs to work is important, obviously. But in the real world, you don't just write a program and then it's done and you put it away. Programs are things that are constantly we're constantly going back to them, right? We're maintaining them, we're updating them, we're improving them, we're debugging them. So it's very important that they are easy to read and understand. So we're going to spend a lot of time talking about that as we go through all of our concepts that we're learning about programming. I would summarize our goal in terms of style with these 4 points here. The goal is to make our programs easy to read and understand, easy to modify, easy to debug, and easy to reuse parts. Okay. The last one in particular is a big deal, especially in terms of, if you're a software company and you're trying to make money, you don't want to have to write everything from scratch every time you need something. You want to write something and then be able to use it over and over again. So there's not a ton of things that we can do right now, given what we've talked about so far. But I'm going to go over just a few things that we can already be working on. The first one is we can use good names for our variables and later on for our functions and constants. Just try really hard to come up with names that describe as accurately and precisely as you can what the variable is doing. Second thing is I have blank lines here. If I had to do it again, I would say white space, because blank lines are important, but also just spaces within a single line are important. That just makes things easier to read. If you use blank lines to kind of separate different sections of your code, that makes it easier for someone looking at your code to identify those sections and understand what's going on. So good names, blank lines, indentation is important. It's not important like it was in Python, right? Because in Python, the indentation actually affected how your program runs. In C++, that's not the case. So you're not forced to use any particular indentation. But indentation is important so that someone can read your program. And so basically, we'll talk about indentation a lot more as we move on. And then the fourth thing is documentation or writing comments in your code. Here is an example of comment. There's two different ways to write comments in C++. The first one is multi-line comment. You start with a /* and then the compiler is going to ignore everything it sees starting from the /* until it gets to a //. And then the second type of comment is a single line comment where you just do // and then the compiler ignores everything else on that line. All right, I think that's all I'm going to say about comments and good names and blank lines and indentation for now. You can read a little bit more about sort of strategies for commenting if you look at the style conventions in the syllabus. Any questions before I move on? Okay. Named constants, really in some sense, this should probably be like item number 5 in this section about style up here, right? You don't ever have to use constants, and in fact, in Python, there is no such thing as a constant. A constant is just exactly like a variable, except that it cannot be changed in your program. First, I guess, let me show you how it works, and then I will motivate it, why you would ever want to use a constant. So for example, in general, the rule is anytime you see a numeric literal in your code, like we see the 12 here, you should take a look at that and think, okay, should I make that into a constant? And I'll talk a little bit about how to decide that in a minute. But in this case, I'm going to say, okay, let's say we decide, yes, we should make that into a constant. 12 represents the hourly pay rate, right? So what we're going to do is up here above int main, we're going to type this line, same exact thing as if we were declaring a variable, except we put the word constant front. Putting the word constant front simply means that the compiler is not going to allow us to change the value of this constant. The other thing I will note is that the convention is that we always use all uppercase for constants. And so if we have two words, we use an underscore in between. And so down here in the code, instead of the 12, you'll see I have hourly pay rate. Okay. Any questions about the how to? All right. So here's why. First reason is, let's say we have a 10 million line program and the pay rate of 12 occurs 4,000 times in the program. And now suppose we need to change that from 12 to 13. Obviously, I wrote this a few years ago. If I was writing it now, I probably wouldn't use 12 for the pay rate. If we didn't use a constant and we have the number 12 occurring 4,000 times in the program, what are we going to do? We're going to have to go through and find all 4,000 of those occurrences and change them to 13 one at a time. What about search and replace, find and replace? Couldn't we just do that? Well, not really, because there may be some occurrences of the number 12 in our code that aren't the pay rate and should not be changed from 12 to 13. So there's really no good way to do it if you're just using the 12 throughout your program. So we solved that problem by creating a constant named hourly pay rate, set it to 12. All 4,000 times in our code, when we need the hourly pay rate, instead of putting the 12 there, we put the hourly pay rate there. And so now if it changes, all we do is we go to the top of our program, change that to a 13, and we're done. Okay, that's reason number one. Reason number two is self-documenting code. So if someone's trying to understand our code and sees the number 12, it may not be obvious what that number is doing there. But if you see hourly pay rate there, then you know, oh, okay, the reason that this is here is that it's the hourly pay rate. That's the role that this is playing in the program. That makes sense. So 2 reasons to use named constants. There will be times when it's actually better to not use a named constant. The most typical example of that I can think of is if it's just like a number that happens to be the number in a formula of some sort. Like, for example, you know, the formula to convert from Celsius to Fahrenheit, you multiply the Celsius by 9/5, right? The 9/5 doesn't really represent anything. It's just a number in the formula. So it probably doesn't make sense to try to make that into a constant. But most of the time you should, I guess I would say, I would encourage you to err on the side of using a constant when you can. One other thing to avoid is something like this, right? Sometimes I see, okay, I have the number 7 in my code. I know Dave said that I shouldn't use literals, numeric literals in my code. I should use constants instead, but I'm not really sure what to call it. So I'm just going to call it 7. Well, that doesn't really help at all, right? First of all, it doesn't help with the self-documenting code because it's just another way of saying 7. Secondly, if I did need to change the 7 to something like 13, then I would have a completely nonsensical statement here, right? So anyway, just pointing out something that you should avoid. All right, any questions about named constants? All right, and if you have looked at the style conventions, I hope everyone has. If you haven't, please plan on doing that as soon as we're done here. Take an hour, read through the syllabus. But anyway, if you have, then you may remember that using named constants in the place of literals whenever appropriate is one of the style. Okay, I'm going to switch gears completely here. I want to just talk a little bit more about the stream extraction operator because it gets a little confusing. All right, I'm just going to stay with the notes here. Okay, so so far we've just used it in a very simple way, right? CN and then a number or a string or whatever. Just one on a line by itself, user entering one thing at a time. It turns out that it's a lot more flexible than that. Let me just remind you that just like the cout statement, the action part of this statement is the operator, not the word CN, right? So CN is an object that represents the keyboard. Num1 is a variable. And so the operator here is the extraction operator. And it says, take something from the thing on the left, which is the keyboard, take something from the keyboard and put it into this variable. Okay. So let's just go over a couple of rules here about how the extraction operator works. Rule number one, the extraction operator always takes one item from its left operand and places it into its right operand. Okay, that's what I just said. Something we may not have talked about yet, though. The extraction operator always begins by skipping any leading white space in the input string. Just hold on to that for a second. May not make sense at this point why that matters, but we're just gonna kind of hang that for now, and we'll get back to it in a second. What's the phrase people say? Put a pin in that, right? And then we'll get back to it in a minute. Third, the extraction operator is customized according to the type of its right operand. So it always reads exactly one value of whatever the type is of its right operand, and then it stops. Anything left in the input stream after that stays there. So this is basically covering what happens if the user types more than one value and then hits the enter button, right? So let's look at an example. I tell the user to enter 2 integers, and then I have 2 CN statements. So what happens? If the user enters 45 space 56, then what's going to happen is the first time I do the extraction operator, it's going to read the 45. When it gets to the space, it's going to say, oh, that's it. I'm done reading my integer. I'm going to stop right there. And so 45 gets put into the num1. Oops. Okay. Now I'm going to execute this statement. I'm applying the extraction operator again. The next character in the input stream at this point is still a space, right? So here's where the rule number 2 comes in. The first thing that happens is the extraction operator is going to skip any leading white space. So it skips over the space and gets to the 5. And then it's going to read an int. So it reads 556 into num2. And then we're done with this statement. Okay. Now, I'm going to see if anyone's still with me here. At this point, after I finished the CN extraction operator num2 statement, 56 got put into num2. Is there anything left in the input stream, or is it empty now? Okay, that's correct. When the user hits the enter button, that puts a character, a special character into the input stream. It's a \n. Tyler almost had it. If that had been a backslash, it would have been correct. So \n is the way that we represent the new line character. And so when the user typed 45 space 56 enter, what goes into the input stream is 45 space 56 new line. And so at this point in the program, we still have the new line character sitting there in the input stream. Okay, that's excellent that a lot of you already realized that. Let's see. Okay, additional detail number 1. In this program, I could have just said both extraction operators on one line instead of putting them on 2 lines. That's totally fine. From the perspective of the compiler, it's just 2 different ways of saying the same thing. All right, what's next here? The new line character, I just talked about that. So let's look at this code. The problem here, and if you understand about the new line character being still left in the input stream, then you probably already know this, but this is an issue that comes up a lot. It's kind of tricky. You just have to be super aware. Remember, at this point in the program, after I execute this statement, we already talked about the fact that there's still a new line in the input stream. Now, it just occurred to me that we have not talked about getLine yet, so I'm doing this out of order a little bit, I guess. But so getLine is a function. I'm going to teach you about getLine right now. GetLine is a function that is used to read a string. And the getLine function reads everything up until it gets to a new line character. So when I say getLine here, what's it going to read into my string? So what's left in the input stream is a new line character, right? And I just said that the getLine function reads everything up to the next new line character. So in this case, what that means is it's going to read absolutely nothing because it's already at the new line character. So 2 things are going to happen that are probably not what this programmer was expecting, right? First of all, the program is not going to stop and wait for the user to enter something because there's already something for the getLine function to read. And secondly, my string is going to be equal to an empty string. Okay, and that's what this here illustrates. I could copy and paste this into a program. Maybe I'll just go ahead and do that. Let's just actually watch this in action. Okay, and the answer, ooh, that didn't work right. Let me try that. Okay. Why is that giving me an error? Never mind. Okay. So before we run it, I want to predict what's going to happen here. Okay. The answer is no, it's not going to be filled with random characters. The getLine function reads everything in the input stream up until the next new line character. In this case, there's nothing to read. And so it's going to be, my string is going to be equal to the empty string, right? So enter 2 integers, 45, 67. You entered 45 and 67. Enter a string. You entered nothing, right? Any questions about why this is happening? Obviously, that is not what we the programmer who wrote this had intended probably. Okay, I'm gonna take the silence as a no. Just go ahead. That's a good question. Strings actually do start out life being empty. That is correct. Okay, what we're going to do? Hold on. Okay, so I want to talk about how to fix this, and I think you may have actually talked about this in lab, but I'm going to talk about it anyway. But before I talk about how to fix it, I just want to play with this a little bit more to make sure you really understand what's going on here. Okay, so here I'm just checking to see if the MyString actually did get assigned the value empty string, right? And just for fun, let's start off with MyString being equal to hello. Okay, so if what I'm telling you is correct, that this call actually causes MyString to become equal to an empty string, then we should see the word yay on the screen when we run this, right? Okay. All right. Okay, what's the difference between endl and \n? In a cout statement, for our purposes anyway, there's no difference. You could use either one. Of course, the \n has to be inside the double quotes, and endl doesn't. I would say that endl tends to be more of like a C++ way of doing things. The \n is more of like a C way of doing things, or actually you could do \n in any language. Well, I don't know about any language, but most languages. And endl is a C++ specific way of doing things. Some people might argue endl is easier to read. Some people might disagree with that. I guess I prefer endl just because it's sort of the C++ way of doing things. But if you hate endl and you just want to use \n instead, that would be fine. Yes, right. There are things you can do with \n that you can't do with endl. Okay, so I think you talked about this during lab a little bit, but since we're here, let me just go over it real quick. The way to fix this is just before I do my get line, I need to get rid of that new line character that's still sitting in the input stream. So I can do that by saying cin.ignore, which just moves the cursor in the input stream over one character. And so if we do this now, if I've done everything right, we should actually be able to enter something. Integers. Okay. All right. Any questions about any of this? Okay, let's go back and I realize that I'm kind of beating some of this input output stuff to death, but it's not something that's pretty different from what you've done before. So I'm going to go ahead and do that, and then on Wednesday I'll kind of breeze through just sort of the syntax for if statements and while loops in C++. Sorry, you probably didn't even hear that. I'm just telling myself what I'm doing. Okay, so additional detail number 3. What it was additional detail number 2 was talking about this new line character. Additional detail number 3 is let's talk about what is white space. White space is defined to be one of 4 characters. It's the space, a new line, horizontal tab, vertical tab. Those all count as white space. Don't worry too much about the tabs. You probably won't see them in this class. So for now, it's safe to think of white space as just spaces and new lines. So we talked about the fact that the extraction operator always skips over any leading white space before it starts reading. So that will include spaces and new line characters. So just a quick example here. If I execute this statement, cin hours and pay rate, and the input is this, the little squiggly there is intended to represent a space. So the first thing that's going to happen is I'm going to cin hours. The extraction operator is going to skip over the spaces and then read 78 into hours. And then the next application of the extraction operator is going to skip over these spaces and then read the 49 into the pay rate. And at the end of that statement, there'll still be some spaces and a new line character in the input stream. Okay. Similarly, down here, if the user hits space, 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 78, space, space, and then hits the enter key, and then another space, and then types 49, same exact thing's going to happen, right? The extraction operator is going to skip over all of the spaces and that new line, and hours is going to get 78, and pay rate's going to get 49. Any questions about that? Okay. All right, just real quickly now, I think this is fairly intuitive, but I want to talk a little bit more about the fact that the extraction operator does something different depending on what is on its right-hand side, depending on the type of the variable on its right-hand side. Let's see. The rule for integers is just, it's going to read until it gets to something that's not a digit, right? So the only thing that can possibly be in an int is one of those 10 digits. So the extraction operator will stop when it gets to something that's not a digit, whether that's a space or a semicolon or the letter Q, whatever it is, it's just going to stop there. The rule for double is very similar, except that a double can also have one period in it, right? So same idea. The extraction operator is going to read through all of the digits until it gets to something that can't possibly be part of a double value. Rule for character values is very easy. It just extracts whatever the next character is, that's it. Although it does still skip leaving white space. So actually, this is an interesting conclusion that we should just make sure we, observation that we should make sure we make. The stream extraction operator can never be used to read a space or a new line character into a variable, because it skips over them, right? Okay, the rule for string values, if you use the stream extraction operator to read a string value, this is actually really important and something that students often forget. So try to burn this in your brain. This is a little arbitrary, but for whatever reason, the creators of C++ said that the extraction operator is going to consider it to be the end of a string if it hits any white space. Okay, so a lot of times students will be writing a program and the instinct is to assume that if the user types, hello there and hits the enter button, that the extraction operator will read the whole string, hello there. That's not what happens. It just reads the word hello and then it stops when it hits that space. Any questions about that? Okay, so I think I'm going to stop there. Make sure you go back and look at lesson 2 and go through this last example here just to make sure you've got it. Okay. And anything we need to talk about as far as logistics go at this point? Any questions about the class? Hopefully everyone's read the syllabus and hopefully everyone's okay just using this Zoom room. It works pretty well for me, so I think I'm just going to go with it unless there's a reason why I shouldn't. Any questions about anything? Save Zoom link next time, post on Canvas. Do you mean the recording or do you mean just the Zoom link? Oh, same Zoom link. Oh, got it. Okay. Sorry, I read that wrong. Yes, it will be the same Zoom link next time. I will post it on Canvas. It's also posted in the syllabus. So I think what I'm going to say is if having it in the syllabus, if having it in Canvas as well as having it in the syllabus would be helpful, somebody shoot me an email and let me know, and I will post it in Canvas as well. Okay. All right. Sounds good. I will see everyone on Wednesday.
Thank you.
Good day. Bye.
Thank you.